Hello and welcome back to Chapter 10. Today we're going to be dealing with Section 9.6 that pertains to graphing and classifying conics. Now so far in Chapter 10 we've talked about parabolas, circles, ellipses, and hyperbolas. These are what are called conics. Now everything that we've dealt with so far in the previous sections had the conics located or centered at the origin or 0, 0. In 10.6 we're going to look at some conics that are not centered at 0, 0, but rather have been translated. Now in your book on page 623 you have a table that lists out the standard form of equations of translated conics. I've typed it up for you to look at here, but it may be easier for you to have your book open to page 623. The standard form of an equation of a translated conic says that if I have a point HK, this point, HK, is the vertex of a parabola and the center of all of my other conics. Now, listed out here, if I have a circle, remember the standard form of equation of a circle that we've dealt with so far has been x squared plus y squared equals r squared. Now the x squared plus y squared is just an x squared and y squared because it was centered at 0, 0. So if you were to take and plug in 0 for h and 0 for k, you would still get your x squared plus y squared equals r squared. Now we're not going to be centered at 0, 0, and that's why we're going to have to plug in some other number for h and k to tell us how much we've translated off from that center point. Likewise for the parabola, you were given the equation, the quantity of y minus k squared equals 4p times the quantity of x minus h equals 1. Still that same equation that we've been dealing with all along, however now it's just being translated off from the x and y by h and k. Same thing for the ellipse. Okay, now we have the quantity of x minus h squared divided by a squared plus the quantity of y minus k squared divided by b squared, that equals 1. Okay, we have both equations for the horizontal and the vertical directions, and the same thing with the hyperbolas. Now, for our first example, we want to graph the equation of the quantity of x minus 2 squared plus the quantity of y plus 3 squared equals 9. Now, this should look familiar to you, and I hope you identify this as a circle. But if you notice, it does kind of look like the form x squared plus y squared equals r squared. What we need to do is we need to first identify the center point, because we know that the center point is where we need to start with our circles when we graph them, and then from there we can calculate the radius off from that center point and go from there. So now our radius is this right here. That's our r squared value. So if I want to find the actual radius, I'm going to take the square root of 9, which is 3. And then I have to identify the center point, or my HK. And h comes from our x value, and k comes from the y. So I see that I have a center point at 2, -3. Now in order to graph this, because we have our center and we know our radius, I'm just going to pick a couple points so I have something to plot off from. So what I'm going to do is I'm going to take my radius and I'm going to add that to my x-coordinate, my y-coordinate, and then subtract it from both, and that will give me a few different points to plot. So let's go ahead and do that. So if we want to calculate some points, I'm going to add my radius to my x-coordinate point. So I'm going to go to +3, leave my y-coordinate the same, which is a -3. So this is going to give me the point 5, -3. Then I'll do the same thing where I subtract the radius, or 2 minus 3, and my y-coordinate will stay the same. So now I get a -1, -3. Likewise, now I'm going to do the same thing with my y-coordinate. So I'll leave my x-coordinate at 2, and I will go -3 minus 3, which will give me the coordinate point 2, -6. And then I'll go leave the x-coordinate the same, and I'm going to go -3 plus 3, and this will give us the point 2, 0. So now when I graph my center point, which we found to be 2, -3, and the other 4 points that I found, I now have enough points that I can go ahead and connect them and make my circle. Now for example 2, it says to write an equation of the parabola whose vertex is at the point -2, 3, and whose focus is at -4, 3. The first thing I would suggest you do is to start out just by making a rough sketch. So if I sketch my focus and my vertex point, so I have -2, 3, which is going to occur somewhere over in this quadrant. This is my vertex. And then my focus point is a -4, 3. That's going to occur straight back. So this is our focus. I see that I'm going to have a parabola that faces, let's change colors here. Remember, the focus is inside of the parabola, so I'm going to have something that looks like this. So this just kind of gives me an idea as to which direction my parabola is going to be facing and which axis the axis of symmetry is going to lie on. This also tells me that I'm going to be dealing with the form y minus k, the quantity squared, is equal to 4p times the quantity of x minus h. The next thing we want to do is identify our h and k values. And for a parabola, those come from our vertex coordinate points. So our h and k is really equal to the point -2, 3. So what I can do now is I can go ahead and plug those in, and I see that I have y minus 3, the quantity squared, is equal to 4p times the quantity of x plus 2. Now I need to solve for the value of p, and I can complete my equation. To do this, what we have to do is we have to look at our parabola and notice that the vertex and the focus both are on the line y equals 3. And we'll come up here, so if you look at this, remember this is the line y equals 3. So I need to find the distance between that focus point and the vertex point, and that is your p-value. And if you recall, the distance is equal to the square root of, and we'll just go 3 minus 3 squared plus a -4 minus a -2 becomes plus 2 squared. So when I simplify this, and here we're looking for a p-value, this is going to give me the square root of 0 plus a -2 squared, which is 4. So my value of p is really 2. Now, because your parabola is facing the direction that it is, our p-value is really equal to a -2. So to complete my equation, I'm just going to plug the p-value in up here, and I end up with y minus 3, the quantity squared, is equal to 4 times a -2 times a quantity of x plus 2. And if I simplify that, then we end up with a quantity of y minus 3 squared is equal to a -8 times a quantity of x plus 2. And this is the equation for that parabola. And if I were to graph it, this is what it would look like. Example 3 says to write an equation of an ellipse with a focus point at 1, 2 and at 7, 2, and then co-vertices at 4, 0 and 4, 4. Just like with the last problem, we're going to want to kind of sketch what we've got here so we can tell which axis our ellipse is, or which direction our ellipse is laying. So if we plot the point 1, 2, we're going to end up with something in quadrant 1. Then we have 7, 2, which is going to be down here. So this is a focus point, this is a focus point. Now our co-vertices are located at 4, 0 and 4, 4. So 4, 0 is going to be right here, and 4, 4 is going to be directly above that. Our co-vertices are the shortest side of the ellipse, so we are going to have something that looks kind of like this. So I see that the long axis, or the major axis of my ellipse, is actually parallel to the x-axis, and this tells me that I'm dealing with a parabola, or I'm sorry, an ellipse of the form of the quantity of x minus h squared divided by a squared plus the quantity of y minus k squared divided by b squared equals 1. Now again, we need to identify our h and k points, which when we're dealing with an ellipse is really the center point. And we can find that center point because we were given our co-vertices, and the center point is really the midpoint of our co-vertices. So we want to find the midpoint of the co-vertices, and to do that we're going to add the x coordinates together, and we have 4 plus 4 divided by 2. And then we're going to go and do the same thing for the y, where we have 0 plus 4 divided by 2. So when we simplify everything, we get 8 divided by 2 is 4, and 4 divided by 2 is 2. And again, this is our h and our k, or our center. The next thing we need to find, because we are given our co-vertices, is our b value. Now on our parabola, or our ellipse, the b value is actually the distance off from the center to the co-vertex point. So if I calculate my distance, now that I know my center, so we'll say b is equal to the distance, which is the square root of my center, which is 4, minus, and I'm just going to pick the point 4, 0, so 4 minus 4, the quantity squared, plus 2 minus 0, that quantity squared. So I end up with the square root of 0 plus 2 squared, which is 4, or a b value of 2. Now I can also find my c value because I was given the focus point. The c value is the distance between the focus and the center. So I can take the square root of my center, which is 4, minus, and I'm just going to use the point 1, 2 for my focus. So 4 minus 1 squared plus 2 minus 2 squared, and I end up with a square root of 3 squared, which is 9, which equals 3. Now that I know b and c, I can go ahead and find a as well. And I can find a by using the equation that a squared is equal to b squared plus c squared. So this tells me that a squared then is equal to 4 plus 9, or 13. So now that I know what a is, b is, and my center point, all I have to do is plug my points into the standard form of the equation. So we end up with x minus 4, the quantity squared, divided by my a squared value, which is 13, plus the quantity of y minus 2 squared divided by my b squared value, which is 4, and this all equals 1. And when we graph this ellipse, this is what it's going to look like. We have our covertices at 4, 4 and 4, 0, our foci points at 1, 2 and 7, 2. The last thing we're going to look at is classifying conics from an equation. And again, I suggest that you open your books to page 626, where there's a table that has all of this in it, and you're going to want to reference that table. For classifying conics, it says that you're given the equation of a conic, and it can be written as ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. This is called the general second degree equation in x and y. And just as we talked about a couple chapters ago when we dealt with the quadratic stuff, b squared minus 4ac, this is still considered our discriminant, and it can be used to help us find what type of conics that we have. This table here is on page 626 in your book, but our discriminant tells us that if I have a discriminant that is less than 0, and b is equal to 0 and a is equal to 0, then I'm going to have a circle. If my discriminant is less than 0, but either b is equal to or not equal to 0 or a doesn't equal c, then I have an ellipse. If my discriminant equals 0, I'll have a parabola, and if my discriminant is greater than 0, then I'm going to have a hyperbola. Example 5 says to classify the conic given and identify any vertices, covertices, and centers. Now, before I worry about my vertices, covertices, and centers, the first thing I need to do is figure out what kind of an equation I have. So if I go through and I use that standard form of the equation to identify my pieces, I see that a equals 2, b equals 0, c equals 1, d equals 0, e equals 8, and f equals 6. Now to use a discriminant, I only need a, b, and c, and my discriminant was b squared minus 4ac. So when I plug those points in, I end up with 0 squared minus 4 times 2 times c. Or I get 0 minus 8, which gives me a negative 8. Now negative 8 is less than 0, so I can narrow my selection down to either a circle or an ellipse, but because my a value does not equal c, I know that I have an ellipse. So now that I know that I have an ellipse, I need to come up with that equation, and to do that, I'm going to group all of my x terms together and all of my y terms together. So let's rewrite our original equation. I have 2x squared plus, I'm going to group my y terms together, so I have y squared plus 8y, and then I'm going to move the constant over to the other side by subtracting 6. And I need to come up with a format where I have something squared with the y terms, something squared with the x terms, and to do that, I have to complete the square. Now, I don't have anything to complete the square with on my x terms, so this is going to stay 2x squared. Plus, now y squared, or for my y terms, I'm going to have y squared plus 8y, and if you remember to complete the square, you're going to divide this term here, so I'm going to take 8 and divide it by 2, which gives me 4, and then I'm going to square it. And because I added 4 squared on the left, I also have to add 4 squared, or 16, on the right. Now I'm going to go through and simplify. So I'm going to end up with 2x squared plus, now the whole point in completing the square is to be able to simplify that. So I now know that I have y plus 4, the quantity squared, and then this is going to equal a negative 6 plus 16, which is 10. To write the standard form of an equation of an ellipse, I then have to go through and divide everything by 10. So I end up with x squared divided by 5 plus the quantity of y plus 4 squared divided by 10 equals 1. Now based on this equation, we had to find our center, our vertices, and covertices. So I can find my center just based off from the equation. And my center is located at HK, H going with the x values, and because x isn't being added or subtracted with anything, I know that that's 0. And my k value is the opposite of this positive 4, which is a negative 4. So I have an ellipse that is centered at the point 0, negative 4. The next thing I'm going to do is I need to identify what my A value and my B value are so that I can go and find my vertex and covertex points. So A, if you remember, is the largest value of the denominator. So A equals the square root of 10. And B then is equal to the square root of 5. Now, to find our vertex points, okay, I know that I'm going to have to take the largest side length, which was the square root of 10, and add that to my y value. So I'm going to have 0, and this is going to give me negative 4 plus the square root of 10. You'll see is a negative 0.837. To find the other vertex point, I'm going to subtract. So I have 0, and when I go a negative 4 minus the square root of 10, I get a negative 7.162. I did just go in and write in where I got those values so that you have them for your notes. Next, we need to find our covertices. So our covertex points are going to come from adding and subtracting our B value to the x coordinate. So if I go 0 plus or minus the square root of 5, I end up with plus or minus the square root of 5, and then my y value will stay the same at a negative 4. And our last example is example 6, and this says to classify the conic given and identify any vertices, covertices, and centers. So again, we're going to start out by identifying at least our A, B, and C values so that we can identify if it's an ellipse, a hyperbola, a circle, etc. So here we see that A is equal to 4, B equals 0, and C equals a negative 1. So when I do the discriminant, I end up with 0 squared minus 4 times A, which is 4, times C, which is negative 1. 4 times a negative 1 gives me a negative 16. So I'm going 0 minus a negative 16 gives me a positive 16. And because my discriminant equals a positive 16, and this is greater than 0, this tells me that I have a hyperbola. And now that I know what I'm dealing with as far as a conic, I'm going to go ahead and group my x's together, group my y's together, get my constants moved to the other side. So we have 4x squared minus 16x minus y squared. Now I know I have a minus 4, but I need to factor out this negative, so that minus 4 is really going to become a plus 4y inside. And then I'm going to set that equal to, and I'm going to move this negative 4 over to give me a positive 4. And now I need to go ahead and complete the square where I can. But before I can complete the square in my x terms, if you recall, when you complete a square, you can't have a coefficient on your x squared term. And because I do, I need to factor that out. So I'm going to factor out a 4. So I have 4 times the quantity of x squared minus 4x, and that's going to be plus, and I'll complete the square here in just a second. And then I have minus, my y squared term has a coefficient of 1, so I can just go ahead and leave that as y squared plus 4y plus another term, and this is going to equal 4 plus, now because of this I had to pull a 4 out over here, I'm also going to have to include that 4 over here, because that's going to be 4 times whatever the term is that I complete my square with. And then I'm going to have plus my y value. So let's go ahead and complete the squares. Looking at this term here, half of 4 is 2. So I'm going to add 2 squared here, which is 4. So over in this spot, I'm going to go 4 times 4. And then I have half of this 4 is also 2. So I'm going to go plus 2 squared, which is also 4. And actually, because we are subtracting right here, we need to subtract that 4. So when we simplify now, we have 4 times the quantity of x minus 2 squared minus the quantity of y plus 2 squared equals 4 plus 4 times 4, which is 16, so 4 plus 16 is 20, minus 4 is 16. Because this is a hyperbola, I know that I need to have my right-hand side equal to 1, so I need to go through and divide everything by 16. So I end up with a quantity of x minus 2 squared divided by 4 minus the quantity of y plus 2 squared divided by 16 equals 1. So I can go ahead and identify my center point. So the center is at the point 2, negative 2. And with a hyperbola, if you recall, a goes underneath the first term, so my a squared term equals 4, which tells me that a is equal to 2. My b squared term equals 16, which tells me that b is equal to 4. So what I have to do now is to find my vertex point. I'm going to take and add and subtract my a value from the center. And because a falls under x, I have to add and subtract that to the x value. So I have one vertex point at 2 minus 2, which is 0, negative 2, and the other vertex point at 2 plus 2, which is 4, negative 2, sorry. So 4, negative 2. And again, just as a reminder, I took the center point and added our a value. So this would have been 2 minus a And this here is really 2 plus a. That's where we got the 2 plus 2 and 2 minus 2. And that concludes our Chapter 10.6 video.